Sorry, everyone. I think we need to get this new link out to everyone.
Okay, I will message.
Yeah. Okay, we're back, sort of. The problem is if people click that link, they might not get access, but Yuchao can try and fix that. Okay, so hopefully some of you are coming back from the new link online, and Yuchao's going to share that link. Do you have the link? The problem I need to work out is how to get access to an Ethernet point in this room. Do you have the link, Yuchao, Matter? Okay. Okay. Yeah, okay, cool, with the new link. All right. We'll keep going. And I'll fix this for next week. Sorry about that. Okay, so yeah, that's this general idea of branching. So there's actually different ways you can use Git, and different companies will have their own preferences, if that makes sense. This feature branch model is really common. This is how all of my projects used to operate. So this is also the model that you will use in the group project, this course. And it's again, it's called the feature branch model. So if someone's working on a new feature, it could be a new button or a new layout or something, a new thing in your app or your system, you would make a branch, work on it, make sure it's all working, and then say to the parent branch, this is ready to go. So, and this is where some of the Git command terminology for creating these things starts to get to a point where you'll either have enough experience to memorize them, or what I really, really, really recommend you do is find a Git cheat sheet. In fact, when I was getting started, I printed one out, laminated it, and sort of just kept it on my desk. And I just had all the commands and what they did, like Git Status that we spoke about yesterday, and Git Checkout, -b, and then the name of our new branch. So this command here is how we make a branch. So I've got some code base, and I say I want to make a new feature. I would, in my terminal, run Git Checkout -b, which means a new branch, and then I can name the branch. So why don't let's do that in a demo. So someone online's asking, is this like a C pointer? Maybe you can make an analogy like that. Yeah, commits are very pointer-esque, but the mechanism that's used is nothing to do with pointers. But it is a really good analogy. Okay, so let's go. Ooh, what is this view? Let's go to our editor. What I'll do for the rest of the live demos is use the terminal that's built into Visual Studio Code. So I've got VS Code down the bottom, the terminal down the bottom, and then I'm just using the editor. But this is just a normal terminal if you've never used Visual Studio Code. So I've got this directory. Do I make it a bit bigger? Can you all read that? Yes? All right. So the first thing we'll do, let's go to our browser, go to GitLab, and again, we need to make a repository. And you'll be able to do this in your home directory of GitLab as well, assuming you've got it all sort of set up. Yeah, I'll keep an eye on the face cam. Thank you. Okay, let's make a new... Should we make a new project or use the one from yesterday? Do you want a recap of doing it all from scratch? Who wants to do it from scratch again to get it? It's a bit of a recap. Yeah, that's a lot of hands. All right, so we'll make a new project, right? So we're initializing a Git repository on some server. What are we going to call it? Branching demo. Let's call it branching demo. And I'm going to just make this in my personal sort of location. We'll make it private, yes. And we'll create this project. Are you able to do something similar on GitLab if anyone is trying to follow along? You got some similar, maybe things look slightly different, but. Right, so we get this repository. Remember we cloned, I saw someone on the forum was cloning their repo and they clicked this HTTPS link. Remember we're using SSH to authenticate with the GitLab server. So make sure you copy the SSH URL. That's something that'll just, it's just a right and a wrong choice. Okay, so we'll go back to our terminal. Let's go into the week 1 directory here, and I'm going to git clone that URL. You might not have to enter a password for your SSH key, but I do because I've configured it that way. Let's see, is the terminal getting cut off? Maybe I'll just make this a little smaller, just in case. So if we look now in this week 1 directory, we've got another folder, another directory called branching demo, and in the branching demo is the readme directory that was initialized when we made the project. Any questions so far? This is a bit of a recap of what we did yesterday. Is anyone following along? And it's, yeah, cool, okay, cool. Maybe what might make it look a little simpler is if we just open this directory in Visual Studio Code straight off, so we don't have the other folders complicating it. All right, so I'm going to make a file. Let's just maybe work on the README file. We'll delete it, like my ambitious project. Will, I don't know, be the project directory for my COMP1531 project. So I've got this directory here. I can open a terminal and, oops, can't spell, Git Status. And I can see that, yeah, remember Git Status is a really helpful command that tells us what Git thinks is going on in this repository, and it's telling me I've got this modified file, which totally makes sense. So I can add that for a commit, whoops, add that README file, make a commit, create initial README content, and I run git push. Let's make this a bit smaller. Okay, someone was talking after the lecture yesterday and asked, if you're here, I'm shouting you out, and asked, I don't get the difference between the adding and the committing and all that. Is anyone else in a similar boat? It's like, why do we have those steps? Like, that seems inefficient or something. And I gave an analogy which I think was decent enough to repeat. So if you imagine going into a supermarket, you got an entire supermarket worth of products, you want to buy a few things, some fruit or vegetables. The adding is putting stuff into your basket as you're walking through the supermarket. It's you deciding what it is that you want to purchase at that trip. But just because you put something in your trolley doesn't mean you own it, right? What do you have to do? You have to buy it. You have to go to a checkout and put all the things that you've added to your cart or to your commit through the checkout and pay for it on a single receipt, a single transaction, which we call a what in this terminology? A commit, a single transaction with all the things that I added, right? Then you get your commit, you get your receipt or something, and that's your commit. So it's a multi-step process because you need time to decide all the different things you want to add into this transaction. You can't walk into the shopping center and or to the supermarket and have access to all the different things at once because it's a big supermarket, because there might be multiple files. So that's the analogy. You've got to add the different things that you want to add and check out or commit at a singular point in time. And then you can go back to the supermarket and do it all again if you really want. We pushed, so if we go to GitLab and refresh, we have this updated README with the changes that we made, right? And if we go back, you can actually see here that that's the message I wrote in the commit when I made the commit. So GitLab's showing me lots of helpful information, but there's nothing new here. It's all just the information from the Git repository. Someone online saying, would the commit be going to the checkout and the push be buying? Yeah, well, the push could be like taking it to your car project. I'm going to simulate it myself because there's only one of me, but we can actually do that quite sort of simply. So this is the main branch. And if I go git remote-v, no, that's the... if I type Git Status always pulls through for us, it tells me I'm on a branch called main. So by default, when you create a Git repository, it will create a default branch. It'll either be called master or main, usually. And this is just where we start off. And if we go back to our diagram, that maybe is hard to see. Let me just... I don't know where the app's gone. There, for some reason, refuses to go away. Does this work now? Okay. This would be like that master or that main branch, and we can make branches off that branch. Oh, yeah. So who remembers the command that we used to do that? It was a bit long. Checkout, yeah, exactly. Git checkout, it was a -b, that's important. And I'll explain what the -b does actually a bit more specifically. So git checkout -b, and then I need to give it a name of the branch. What's some feature that we can work on? Let's think about this. So we've got this README file. We can be like add JS file. Okay, and then Git tells me I switch to this new branch called add.js file. So what should we do on this branch? We should do what the branch name says it's doing. This is the important part of a feature branch model. We should be doing what the feature's name is. We shouldn't go off and start making the C file on this branch, right? Because it's just not what... The labels are really important when you're working on things like this. In fact, when we mark the group projects, one of the things that we take into account with the marking is everything labeled correctly? It's really common and easy when you're starting out to give things lazy names like my feature. That's not a feature branch name that's acceptable. In industry, that wouldn't be acceptable, and we wouldn't accept it either. Someone's asking, why are there two branches on the end of the slide? I mean, the answer is, so I think what they're asking is, why does it end with two branches? The answer is, like, if a project's living and it's being worked on, you're always going to have multiple branches. Maybe one day in theory, if you finish a project, what does it mean to finish a project? You could, like, merge them all back into one and, like, end the project, but in reality, there's always going to be people working on new features and new things, and so you're just going to have multiple branches that are living simultaneously. The goal isn't always to merge it back into one. Although the goal with each feature is to complete the feature and merge it back into the development branch or the main branch. Okay, so we made a new branch, and everything looks exactly the same, right? Do we agree? Everything looks the same. I have the same README file with the same content. Although if I run Git Status, we can see that I'm on a new branch. It's telling me, like, I know you're on this different branch. It just so happens that this branch and the main branch are identical, because I've not done anything. So let's do something. We said we were going to add a file. Let's add a program.js file, and all we're going to do here is console.log, hey, I have started. And remember that we're not talking about JavaScript yet. I'm just doing this as an example. We made a file, added some code to it. So if we run git status here, we can say, okay, there's a new untracked file. Well, let's add it. Let's commit it, create JS file, and let's push it. And this is interesting, right? This is really interesting. So remember we said that Git repositories are completely distributed. So the remote Git server and the repository on that server, it's up to date as far until I last pushed to it. Does that make sense? So when I pushed before, I gave it my updates, my commits. I sent my commits up to the remote server. But I've not told it that I've made a new branch. It's not aware of this new branch. So I've gone to push here, and it's given me an error. My branch locally doesn't exist on upstream. Upstream is the term. If you're a good student, maybe you'll be writing down, like, if you hear terminology, because there's so many new terms with this stuff, and there's no way around it, so you've got to just make a note. So upstream usually it refers to the remote or the cloud-based repository. This branch doesn't exist, so basically tell me what to do. I don't know what to do. Should I make a new branch called the same thing? Is there another branch on the remote upstream that you want me to point to, or what do I do? And you know, Git's very nice, and it tells us a command that we can use, and in fact, this is the command that will solve our problem. And what it's doing is pushing, so saying, hey, upstream, make a new branch, and push what we've got down here up to that branch, all in one line. And then it's even saying, I've never seen that, that might be sort of new, you can have this happen automatically whenever you come into this circumstance. So I just copied that line, pasted it in. Again, I got to do this. Okay, and it's pushed it up. And it even tries to show you that my local branch called add.js file has been pushed up to the remote branch add.js file. So if we go back to GitLab and we refresh here, what's going on? We don't see the new file, even though I pushed. Does anyone have an idea? Online or in person? I got to switch the branch. Now this is like kind of crazy. There are now, remember we said we're no longer linear. We're branching off into multiple dimensions. So the changes are clearly here, right? There's this add.js file with my program.js. I've got 2 copies of the repository on the remote server and on my local machine. So there's now, if you think about it, 4 directories of this code base. 2 on this remote server, and I can switch between them, and 2 locally. And then if you think about it again, and one of the diagrams in the slides was really helpful for showing this. Yeah, okay. There was another one. No, okay. What I want to show here is that, so if this is main, right, we made a commit, then we branched off to add.js file, and then we also have main here. There's an extra commit on add.js file that doesn't exist on main. Do we agree with that? Sort of. Another way of saying that is that add.js file is a commit ahead of main. And there's a way to actually look at that, and that's with this history button. And you can see the history of the commits that have happened on each of these branches. When you create a repository, it creates a commit. So that we've got this initial commit. Or I might have called it initial commit. Then I made this, I changed the README file, so that's the commit there. And then I created the JavaScript file. And that commit contains, if I click it, the changes that occurred in that specific checkout, in that specific commit. If I instead go back to the main directory and view the history, which the button is where? Okay, that was weird. It's missing that new commit. So this is what takes a bit of time to get our head around. We've got two branches, the main branch, the JavaScript file branch, and that's had progress working on it. Does that make sense? So someone online's asked a good question. If we now make a commit on the main branch, will that be visible on the add JavaScript branch? And the answer is no. They're now two separate points in time that can have separate iterations on them. Now, can someone tell me why? This sounds complicated, right? Who thinks this is like, what? This sounds like hell a little bit. Like, this is a lot to manage. We've got to agree on that. It's a lot to keep track of, clearly. No? The rest of you are like, this is too easy, Jake, hurry up. Do we think it's a bit complex? But can anyone think about why we want it to be like this?
In a larger scale project, you have different parts of functions or different parts of things you want to do.
Yeah.
And you can under control, so like you can control it on the different sections of the branch. So that like different features that okay, this part of the code actually take charge of this part of the features.
So basically saying, well, we're working on different features, so they need to have sort of different histories. That's one way of sort of answering it. There's another that I'm wanting to get to. Someone online said it's the multiverse of madness, which is sort of accurate as well. Sounds like keeping track of multiple timelines. Yeah, this is what like Dr. Strange is doing in that, when he's like trying to find the only pathway that ends the way we want. But there's another answer I'm looking for. Why would we want to maintain separate histories?
Like once you screw something up, you can go back.
Okay, so we just said, so if you screw something up, you can go back. There's sort of another reason. In case we lose something, but that's just a reason to have a backup, right? There's something else really important. That's it. Yes, that's it. It's because we work in teams. Imagine if I'm working with Madhav or Yuchao, and I'm working at like 2 a.m. and I'm working on a feature, I'm writing some code, and in my process, I have to sometimes we have to destroy, we have to refactor our code. We have to take things apart. At the same time, Madhav or Yuchao is working on a different feature, and they're in the zone, and all of a sudden, their file updates and all of their work is gone because I screwed something up. That would be worse than this, right? Do we agree with that? So what we have is this model where we have different histories. Madhav has his history, I have my history, and we're both happy. We have two features being worked on at the same time from the same point in history. Yes? Maybe it makes sense to hear, and in practice will be a different story. Okay, that's a fantastic point. You were the one yesterday that was trying to sort your group out, wasn't you? Yeah, good thinking. Yeah, so someone just said that, so all this sounds good, but then this sounds difficult to merge back. how do we get both at some point we need to merge the two branches so that both the features go out to our product. And that's something that Git helps us basically a lot with. And you'll see sort of how that works. Yeah, okay, cool. So it sounds like we're all getting the idea of it. Practice will take longer, and that's completely normal. All right, so let's go back to the slides. There's no limit for the number of branches. Okay. If there's no limit to the number of branches, that means that there can be multiple branches. If there's multiple branches, how do you switch between them? You use checkout once again, but you don't give it -b. So the -b means new branch, basically. So you just give it the name of the branch, and if it exists, you will get a copy of that thing. And actually, that's a really fun demo, isn't it? Madhav? To check out a new branch in VS Code is kind of fun. Let's do it. So let's clear the terminal. Now, I've got, how many branches do I have here? 2, what's the other one called? Yeah. So I can go git checkout main. What happened? I switched a branch, and then what happened? Yeah, because main doesn't have the commit that contains the change that added the file. And if I go back, what was it called again? JS file, yeah. The file comes back. I can quickly switch between branches and get full changes with the history. You also might be thinking, wow, this sounds like hideously inefficient. Is anyone thinking that? Like, I've got this one project and I've got how many copies of the files? Like 8? And if I make another branch, I have to double it all again. And this has got 2 files. I've got projects with thousands of files. Like, that sounds crazy. Now, this is where we just have to appreciate Linus Torvalds, who wrote Git. Actually, there is not multiples of that file stored on this machine. Git's actually smart enough to know if you've got 3 branches and the same file exists on all the branch, I only need to store it once.
Is that the same idea with the Linux system?
The operating system, no, not really. The operating system itself will have to have a file on the disk. Git's doing its own sort of stuff to say, to reduce basically the redundancy of keeping all these files. But a copy definitely exists on the remote server. So it's just within a singular machine. In fact, it's smart enough that if I have this program.js file and I add a line, whatever, it doesn't matter what it is, it only, across the commit and even across the branches, it only keeps what's different in the file, which is pretty cool. And that's the same logic it uses to address our concern on how do we merge things back. It's actually keeping track of everything line by line over time so that it can figure out how to put things back. But we'll talk more about that later. So someone said, sounds good for teamwork and not breaking other people's code, but painful to navigate. That's kind of true. Git can be painful. 100% of you, and if you've done Git stuff in Teams already, you'll have definitely know what I'm talking about, will screw up something with Git. This is ringing a bell for anyone? You'll screw something up and your heart will sink and you'll be like, have I just deleted everyone's work? Because you can do some really weird stuff with Git. Like, we're just showing the most simple commands. There's a lot of weird stuff you can do. And sometimes you get into a hole. I'm thinking of one case in particular where I sat with someone senior and we wrote this, we probably spent 3 hours writing something. And then I don't know what happened. I went home, skipping on the way home or something. And then I never pushed the code, or I never did anything with it. And then completely forgot about it. And then 6 months later, the person was like, where's all that thing we did that was really good? And I'm like, oh shit. I think we found it somehow, but stuff like that will happen, or you'll do something, you'll get stuck, and then all of a sudden all the files will disappear. And you'll be like, oh my God. But 99% of the time, everything's recoverable. And, right, you've got to really know what you're doing to remove everything locally and on the remote server. It is possible, but you've got to really be quite good at destroying stuff. But I'm sure it'll happen. Sorry? Oh. Deleting a file?
No, not delete the file. Alter the definition of a structure, for example. How do you merge that if you have the declaration of the structure before and after?
So the question was, let's say if basically, let me rephrase the question a bit. You've got a line, and there's a modification to the line, not an addition or a deletion. Is that right? How does Git manage that? The answer is it tries its best to look at. So there's always a history. A modification happened at some point in history. And the answer is there's a few ways to resolve it. If you've got multiple people working on the same line, you've got two solutions, maybe more, but you say either the other people were meant to have my change first, and then they do their change, or their change should supersede mine. Basically, you've got to pick in that case. If that's the trickiest case and we're talking about merging right now, so we're almost on the topic. So merging is this idea that we've got multiple branches, we need to take them back into a singular branch. Additions are sort of easy, because you can just apply the addition to the other file. Deletions are sort of easy, you just delete what was in one branch from the other. It's when there's a modification to the same line that we get into where you need manual intervention. And that's the answer. We manually decide as the programmer what needs to win out, like which change is correct, or perhaps a new change actually that's some weird combination of both, which is also common. Someone said online, I am in fact good enough to manage to delete every copy. So congratulations, professional. All right. So we've got two branches. I've got my feature branch, which was called add the JavaScript file. I've got the main branch, which doesn't have that change. What do I want to do now? I want to get my change back into the main branch. And who would have thought that the term for the command for that is what? Oh, come on, it's right here. Can everyone say it? Git merge, git merge. Now, actually, there's a bit of something funny happening here. If you're merging something, what does that imply? Yeah, but what does it? That's what it's doing. But what does it imply? If you're merging, well, what I'm trying to say is it's implying that you've got two things to merge. Right? You need two things to do a merge, but there's only one operand here. So how does that sort of resolve itself? And the answer is it's implied that the branch you're currently on is getting merged. Hold on, wait, I might get that wrong. If I'm in a branch, git merge. No, so it's the branch that I give here gets merged into the branch that I'm currently on. Is that right? That's right, yeah. So that's the two. That's how we resolve that issue. There's no, okay. There is, yeah, okay. So if we think of branches as, branches are timelines of commits, right? So if you've got two branches, and both branches should share a common ancestry. Does that make sense? They had commit, 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 branch, branch, commit, commit, commit. So they've got this common part here, and then some different part here. Depending what you're merging into, the camera's lost me. Depending what you're merging into, oh no, maybe the camera hasn't lost me. I don't know what's going on with the camera. Depending what you're merging into is depending what are you putting these commits from the future ahead of mine, or do you need to sort of, it's just It's like, what's the base branch that you're merging the other one into? But in effect, they both will appear to look exactly the same at the end. There's actually different ways to do a merge, different like approaches, and we'll talk a bit about that. Let me just figure out what's going on with the camera. Okay, hopefully that was enough to fix it. So yeah, let's read the slide. Once your branch is stable enough, so once you've made some changes and you're happy with it, it's ready to go back, you can do a merge. And you specify the branch you want merged into the current branch. So before we get to this table, let's do this with our demo. So what do you think we want to do here? So we've got this feature branch with some changes, and I'm just going to say that I'm ready for these changes to be applied. So I want to merge these changes, this branch, into main again. So so what do I have to do this? And just to give you a bit of a recap, we're currently on the add.js branch. So what are the steps I need to do? Go to main, great, love it. How do we do that? Git checkout main. So switch to main. Okay, that's interesting actually. It's not letting me switch because it's telling me I've got local changes that I've never pushed. And so it's warning me that potentially I'm going to screw something up. The change here, you might say there's no change. I actually added a new line here that wasn't there originally, and so it wasn't able to, it's warning me basically that I never pushed it. So I'm just going to delete that line. Or alternatively, if we wanted to keep that change, what would we do? Add it, commit, exactly, add it, commit it. Yeah, all right. So now we can check out main. I'm back on main. And what's next? And what am I going to merge? Add JS file was the name of the branch. So I'm going to, and now again, just to recap, I know I'm repeating myself a lot. What's different between these two branches? Yeah, there's one extra commit on this branch, this feature branch. So I'm going to merge it into the main branch. You look confused. Add.js file had one extra commit than main. It had the commit that added the JS file. You'll take my word for it. If you look at, yeah, question?
You had a state on add.js file and did git merge main, would it remove the JS file?
Super interesting question. Okay, so the question was, if I was on main, so if I swapped this, if I was on main, and this is what you were asking before, right, sort of in another way. If I was on main and merged in add.js file, no, I'm on add.js file and I merge in main, sorry. What's going to happen? What do we think would happen? So there's a couple of options. Would it delete the JavaScript file? Who thinks it would delete the JavaScript file? Okay, we've got one hand. I hope everyone else puts their hand up next, because it's really, anyway. Or who thinks it's going to, I guess, not delete it's going to keep the JavaScript file? Okay, wow, okay. So people think we're going to keep the JavaScript file. In fact, we will keep the JavaScript file, because it's going to look at the two histories and say, oh, I've already got that commit. There's a new commit, like, it's not, it merges the timelines. So we really are like Dr. Strange. And it says, that already happened to me. I've already got that commit, that first commit, right? I've already got it. You've got nothing to add. In order to delete it, there would have to be a commit that deleted the file. Yep. Yep.
So now you guys can add on
Yep.
one branch and a different add
Yep.
on the other branch, and then you merge. Would it just add the new file, or would it replace the JavaScript file?
It would just add the new file because there was a commit that contained a change to add a file. That's it. There was not a commit that added a change to replace a file. That's a different operation. So, and this is the whole point, right? You can imagine if you've got two people working on a code base, I add 5 files, you add 5 files. They're not the same 5 files. We want 10 files now.
How does it deal with the main file? For example, they have 2 files that have the same name, they're different.
Okay, yeah, that's a bit of an edge case, but it does happen all the time. What happens if in those 5 files we each make 2 of them with the same name? Basically, when we do the merge, Git will say, hold up, partner, I don't know what to do here. I've got 2 different commits doing the same thing, something's wrong. You can either accept one, the other, or manually sort it out yourself. So Git will be smart enough to handle, I would say, like something like most operations. In the cases where it isn't able to handle it because there's a conflict, it throws its hands up, has an absolute panic attack, and then just you have to go fix it. And we can simulate that in a demo in the future. Someone said online, I live in Kensington, but I'm super lazy, but the ping is making me reconsider in person. Well, that's good. That's good. That's good for me. If main is updating while you are working on a branch, do you need to merge main into the branch? Oh, that's a great question. That's a really good question. So let me rephrase it a bit slower. I'm working on a feature that's branched off main, and this person's asked, well, what happens now if some other changes happened to main? So maybe some other feature got completed, that got pushed into main. So now main is ahead of my feature. I branched off before those changes were in. Does that situation make sense? The answer is yes. It's very likely, and the exact moment that you decide to do this is up to you, but at some point you're going to need to get those changes so that you can consolidate. So you could just merge it in. That's pretty common. Git merge main. There might be a bunch of conflicts. It depends how big the change is, or that just merges in, and then you keep going. If you don't do that, what's going to happen is when you merge back into main, there's going to be that conflict again, because you never resolved the conflict. At some point, right, when you do a merge, you're going to have to resolve conflict. We're like conflict resolvers. All right, so if we just go back to our demo here, we merged, that magnifying thing's not very helpful. We merged add.js into main, and it's telling us what the merge did. There was one file changed with an insertion, and it created the program.js file, which totally adds up. That makes sense.
When you merge main into your branch, main still exists. So when you merge branch into main, does that
Yeah, the branches still exist. Yeah. We have to delete the branches if we want them deleted. Yeah. Yes, they can. Well, it depends what you mean. 2 people on different laptops, let's say, have cloned a repo which has a branch, and they're both working on the same branch. Once again, they'll both go to push the branches, and there'll be a conflict. Okay, that's another really good point. It's in most situations, if you're working on any serious project, you actually will not have permission as a developer to push directly to a branch on the upstream repo for that exact reason. You want to avoid that. That's a really bad situation to be in. What you want to do is a merge request, which we'll explain a bit later. But you kind of want to avoid that. Okay. There's some issues with online that I'm just going to have to fix next week, basically. All right, so we did the merge, but oh, there's a question? Yeah, that's another way of putting it, yeah. If you're merging, if on the branch, okay, here's another way of putting it. You can only really change something on the currently active branch. So I'm on main and I'm doing a merge, absolutely nothing's going to happen to the other branch. I'm merging it in. That's the thing I'm changing. It's not that naive. It's a good question. There's two approaches it can take. One's called the fast forward approach and one's called the merge approach. Either what it does is goes to remember branches have a shared history. We said that. So one way that it can do it, this is a bit technical. You don't really sort of need to know this, but I mean at some point you do. One thing it does is it rewinds both histories until it gets to the same point, and it applies the commit one by one to catch up.
So the file in the main is still in the main, it's just been updated.
Yeah.
And the file in the feature branch is still there.
Nothing changes to the feature branch if we're merging it in. That's one way that it does it. The other way that it does it is a merge approach where it doesn't do it through the commit by commit. It just sort of looks at all the changes at once and says like, okay, how can I make these changes? And tries to figure it out in a singular point. And there's benefits to both. I think that the default behavior is it's changed, I feel like. Or it used to be merge, and then now it doesn't actually have a default and it makes you pick. Something like that. So.
Isn't a branch just some directory? Because now it sounds like different branches just different directories.
All a branch is a sequence of commits. The way that it actually keeps the directories is magical internally to Git. We don't have to think about it. Someone online said, I assume on the local version of this, they're talking about YouTube again. Okay. All right, so we did the merge now, but we haven't pushed. Because another way of thinking about a merge is a new commit. Except I didn't actually make the changes. Does that make sense? And anytime there's a commit and we want to get it up to the upstream, what do we have to do? Git push, yeah, exactly. So I run git push on the main branch. It's really annoying. And it makes that change. If we go back to GitLab, we're on the main branch. We refresh here. What do we see there? The new commit that adds the file. This is the main branch, not the feature branch. So now, these two branches have identical history or identical commits, and we could delete, if we wanted to, the add.js branch, because assuming the feature's complete. What's more likely is that your boss basically goes like, that's not what we want to do, you need to do this, and you're not finished, you have to keep doing more stuff. And you go like, oh, and you got to go and do it. Whew. Do we want to quickly finish the Git stuff? We've got one more concept to talk about, and then we'll do the break, because then we'll do the JavaScript stuff. Does that sound good to people? We've got a bit more in the tank for finishing this off. Okay. There's a table here that I'm not really going to go through, because it'll be in the PDF notes, and it's probably one better to just review. What it's describing is what Git will do in different scenarios. So a lot of the questions you've been asking, I've sort of described this. This is just another way of putting it. So it's all, do I have commits on my main branch that don't exist on the remote branch, on the feature branch, or does the feature branch have new stuff that I don't have? And in all of these different variations of circumstance, this is what will happen and what the outcome will be. And this is just a very small snapshot of just some of the possibilities. So someone asked, in fact, what I said before is listed in this slide. In most industries, and when we say we don't, this is probably not the best way, in most companies, let's say, in the software engineering industry, you actually have something called branch protection, which says that you are not allowed to merge your branch into master on the command line. And the reason for it, someone actually identified, it's because if everyone did that, everyone's same branches would mutate. Does that make sense? They would all be different, and that's really, that's a headache. You think merging 2 branches is hard. Imagine having to merge 8 at once, because you know what I mean? So we don't want that to happen. So the way we solve this problem is by saying that the repository on upstream, the one on the server, is like the hero repository, and only it can update the main branch. Everyone else has to politely request to update the main branch on the upstream. And that is called a merge request in GitLab. On GitHub, it's called a pull request. That concept is really important. And I think we either have branch protection on in the projects or we check it, one or the other. I can't quite remember. Someone's asked online, I love these questions, I mean, can you undo commits? And this is, when you start getting into, we'll have a lecture specifically on changing history, because that's really what you're doing. The answer is yes, you can undo commits, but what happens if you undo a commit, but you already pushed it and someone else already built on it? But yeah, someone in the front row is like, oh, don't ask us. Exactly. The answer is it gets complicated. But these things happen. These things happen. It might be a year later, someone's going through and going, what the hell is wrong with this project? Oh, there was a commit a year ago that introduced a bug. This is really common with security incidences. Oh, there was a change made 16 months ago that made such a small change, but it caused a bug. We now need to patch this bug. That's not the best example. The best example, actually, and this is also something I've seen happen, is that someone in a commit added a secret key, like a password, and now that password is distributed to all the computers or the repositories that cloned the repo. And we don't want to just delete the file, because why? Because everyone's got the history anyway. I probably should show that before I do this. If I delete, let's say in this demo, right, let's say I'm on main, and I go, and I merge that branch, and I go, that was rubbish, Jake. We don't want this file. That was really bad. Delete it. We delete it, we run Git Status, and just like we can add files, Git can track the deletion of files. I commit this. This also confuses people. You add the deletions as well. Right, so I add program.js, but that's adding the file being deleted. I know. We run Git Status. We can push. We can make a commit. Delete JS file. Oh, you know what, actually? Okay, hold on. I can actually do both things I wanted to do in one demo. How cool is that? So let's undo that. This is the first time I said undoing is complicated, but it's not complicated if you haven't pushed yet. Why? No one else has it. That's right. No one else has had it even chance. It's never gone out my computer. So git restoring staged, and I need to give it the file. Whoops. And that file now is back into this state, which is not staged, and then I can just go git restore program.js, and you can see the file came back. So you can see something weird is going on. Like, this is not usually what our computers do. Git is doing, it's kept the file somewhere secret, basically. It's pretty cool. Okay, so now we're actually back to where we started. Let's say I check out on the add.js branch. And I'm on this feature branch and I go, oh no, I really shouldn't have added that file. Or another example is I really wanted another log here, I think. So I add program.js, I commit it, update JS file, and I can push it to the, when I push it on a branch, it's only pushing it to that branch. So now this feature branch is, again, one commit ahead. What I wanted to point out here that I can check the log, and the log shows me in the terminal, right, all the commit histories. And just like I can check out branches, I can actually check out specific commits. And now we've gone back to the commit that didn't add the second line. And if I get back onto the add.js file branch, we get the line back. So another way to think of branches is just a commit. Branches are really just a commit. That'll hopefully set in at some point, but it probably won't yet. Yeah, I deleted it through VS Code. Yep. Okay. So I'm back on add.js file. I've got this change here that main doesn't have, and I made a claim before that we typically don't want to change main locally for that protection reason. Agreed? I know, bear with me, I know I've been talking a lot. So, and I've pushed this up. I'll prove it by refreshing here and viewing this JS file. We have the 2 lines here, but we want this change on main, but I want to do it safely. And that is the merge request. Now, the merge request is not a Git command that you run on your computer. It's a process that you engage with on the remote Git server. So it's all done through the user interface. In fact, GitLab and GitHub do this. They try to be helpful, and they say, do you want to merge request this branch because you've made some recent changes to it? And I'm like, yeah, sure, yes, please. And it's even telling me that, well, in this case, like, it knows I've only got 2 branches. So it's like, do you want to just merge request this branch into main? And that is what I want to do. If you think about it, right, this is exactly what a merge does locally, but I'm asking whoever owns the main branch to do this. And I can give some information, and we'll talk a lot in the future about what should be in a good merge request. And like a good commit, it just describes, why I'm doing this. You have things like reviewers. When you're working in projects, right, you don't just blindly accept changes. It's got to be reviewed. Is this code good? Do we want this? Is this the right way to do it? So you can say, oh, I want Jake to review it because blah, 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 blah. Or, or the reviewer's there, the assignee is the person doing it, whatever. That doesn't matter, and we can just make a merge request. And now we have this open merge request. And the most useful tab on a merge request, so I maintain an open source project that gets lots of merge requests. And so when you get a merge request for a project that you maintain, you're the owner, the team lead, whatever it is, the first thing you'll do is check the overview, read what are they doing, what's the name of it, where that description is. I don't even know where to put that description there. And then I look at the changes, and I want to know what is this person trying to change in my special main branch. And you can see the red is removed, the green is added. it's removing the hey I have started, and it's adding the hey I have started, which looks confusing, but it's actually because why? Does anyone know? Yeah, there's a new line character at the end, exactly. And it's adding this, this second command here. So as the reviewer, I say, yeah, this is good. This isn't going to cause any issues. What I should really do is actually clone this down, maybe test it, use it, make sure it's all good. But this is straightforward. And then I find the button. Where's the merge? Where's the accept button? Oh, you might be right. Yeah, you're right. Because I use GitHub 99% of the time. GitLab is only for this course, and it's week 1, so. And so I say, yeah, I approve this because I've been assigned as a reviewer, and I'm happy to merge it. And I've even got an option here to say, so GitLab actually knows that most people use the feature model, so it's saying, well, since the feature's complete and you're merging it in, we might as well delete that other branch. And I'm like, sure, that sounds good to me. So we merge it, and all that activity is tracked. The status is updated to merge, which is pretty cool. And if we go back to the repository sort of main view, there's only that one branch because we deleted it. And we have the update. Okay. That was pretty hectic, I think. Does everyone agree? Question? Or yes, hectic? Yeah, could. Only one person agrees.
So let's say you have 2 feature branches, and you merge one, but you're still working on the other one.
Another good question. Yeah, great question. So if you've got 2 branches, one merge request goes through, what happens to the other one? They've got to pull main back in.
So yeah, they just merge it back, then...
They just merge main back in, then do the pull request, the merge request. That's one way of solving it. So someone online says, has someone in the past damaged code so severely by merging it that this rule exists? I mean, the answer is that once a project gets